Hi folks, it's Jason Wampler with another episode of Wampler Engineering Minute. I'm your host, Jason Wampler. I went to Del Taco. I asked for a taco salad. They gave me nachos. I don't know what is wrong with these people. Anyway, I'm struggling with this. I'm not having a very good time with getting this collar. You know what I need to do? Oh my God, that's why. No wonder. Well, I need to chase the threads on this silly thing. That's why. Well, yeah, that is my fault. I need a tap and die set 6mm or 1.0 pitch on the threads. I need to clean up the threads on the snout. But this is my fault that I'm not doing that. So I'm just gonna run this on as best as I can. Oh, sheesh. Just hope I don't break anything. That would be a horror if I did. Again, if you guys, when you're doing this type of work, you just kind of go back and forth. But remember too, as much as you go back and forth on some of the stuff, think about this. Harbor Freight has tap and die sets, metric and standard, for a little under $30. Save yourself a lot of headache, because if something breaks that's attached to a very large part that's complicated and buried in the mechanism, guess what? You're not probably not going to be able to repair it, and logistically, it's going to be so difficult to replace. You're going to end up throwing out the entire project, and that's a prophecy of doom right there. I guarantee that's going to happen if you're not careful. If you are not careful, if you gotta pay attention. You gotta hold on. Okay. Now, since I can see, now it's showing up the bend. Okay, so I'm trying to knock this thing into place, do this visually, and I don't like doing this, but this is showing up the bend. I don't recommend this unless you know what you're doing. Okay. Oh my God. I don't know how this happened, but this is a critical mistake. Again, I'm just trying to keep me in your prayers at this point. I think I remember. And now from here, again, you grab onto it like this. You grab onto these with this like that, and you have somebody help you out. Maybe in my case, I need a girlfriend or even a wife. But there you go. Now you can't see what I'm doing. Okay, let's. Okay, so now, see what I'm doing, I'm taking two true surfaces and butting them up together as best I can. So see, they're pounding it and they're bending it, but see, the thing is, I can still see it going up and down. It's just going to vibrate at this base. So now I'm going to have to leave the collet as short as possible. I get so angry. Manufacturers are so cheap. They especially Chinese manufacturers, they're so cheap. They want to pay their workers 50 cents an hour. They disregard labor and safety laws. They disregard environmental laws. They manufacture stuff as cheaply as they can. They don't realize that the stuff they manufacture is so cheap that it simply no longer serves any practical use. It does not have practical use in the real world. Now, I'm going to put an extension on this, but I'm going to run a locking nut. And this is going to vibrate like crazy. And the problem with it, all this force I'm exerting on this is going to end up... Okay, so I need to go ahead and get my second 10 millimeter wrench, which I'm so thankful I have. Oh, there it is. Let's go ahead and put this guy down here. See, every single show is an adventure. I just don't want this show to end up in heartbreak. But you know what? I want you guys to see what happens if it does. This is what happens if you make mistakes. And this is what happens if it does. So, hold on. Let me get this collar nut. This is a jamming nut. They're half as wide as regular nuts. Okay, so now... Oh yeah, absolutely, positively. I can absolutely, positively see how it's got down doggy on one side and up doggy on the other. Well, shoot. Okay. That might have actually done the trick. Folks, I've been a mechanic since I was 15 years old. I'm 53 now, so it's been about 38 years. I've also been an engineer for 23 years. So it looks like this is about as true and straight as I'm going to get it. Now comes the really, really hard part. We're going to get this cutting wheel on. This is made by Weiler Vortex 3-inch cutting wheel, 1/16 thick, 3/8 arbor. It's metal reinforced on one side, of course. There's those cheap Chinese manufacturers. They just want to do just the bare minimum to just barely provide a product that just barely works. I know at some point in time people should start becoming ashamed of themselves and how how poorly they do their jobs, but well, such is life. Okay, so we have two fat washers, and I like to take the washers, find the round side of the washer. That's the side of the material that faces up towards the machine underneath the punch that punches it out. The flat side of the washers, you want the flat side of the washer towards the blade itself. That gives it more complete contact area instead of those rounded lifted areas that are going to provide an air gap because they're routed upward. And unless the washer collapses, it's not gonna mate with the surface. So look what we have right there. We have an air gap, but I want to show you something about how to solve that. The problem is I'm hungry, and we've got to terminate the video. We're at only 9 minutes. I've got to go across the street, and I've got to get an O-ring, a rubberized O-ring for that. That'll take up the gap and the inner diameter around the arbor itself. Now I could eyeball and glue this in place. That the problem is, if I'm off by a little bit, then not only is this arbor going to have a natural bend in it, this saw blade is going to be offset as well. I'm already working with the handicap of having had to straighten out the threaded portion of the arbor of the tool itself. So I'm gonna go ahead and opt to get a rubberized O-ring in there. It'll straddle the outer diameter of this particular post. It'll take up the slack in the inner diameter of this particular arbor. The print side facing outward, of course. And then, of course, because I can't get a nut past this hump, I'm going to run another jam nut down. There's a section in the middle that isn't threaded. This is a two-sided stud. You know, I want to sing praises to the place that I go to for this material, but unfortunately I cannot do that because of copyright infringement. What I'm going to do, I'll take this stud and this cutting wheel with me, and maybe I'll run across the street and we'll shoot another 10-minute video and I'll show you how it's done. However, I don't have the electrical hooked up to this particular tool yet. I just, I tell you what, we'll just do one video in one fell swoop. I'm going to take care of this on my own. I don't want to be putting my personal disasters on public display, but I just want to show you some features of this motor. This motor was interesting because of the fact, let me just get this jam nut on here. I'll hold that, I want you guys to see what I'm doing. Almost like rocketry. I'm not really getting anything done. Oh, I promise you'll see this. We're going to use these tools eventually. There you go. That jam nut is seated down in the non-threaded section of the hip of the stud itself. You can barely see that they're like miniaturized exhaust studs on very, very, very small gas or diesel piston engines for for the exhaust ports. So I just wanted to jam that in place. I'm kind of looking at it now. I think I've got it trued up as best as I can. I'm pretty good at eyeballing things. Like I said, I have a lot of experience with mechanical experience, but the problem is it's just, this stuff takes up time and money. I did something with it foolish this morning. I pounded on it to get the bearing out of its press fitting. I wanted to get the cover off. I put too much glue on the back side of this motor with the old gang, which is black. It got in between the rotor and the field windings, and it caused the motor to hang up. I had to take everything apart, sand it down, and clean it up. The process of doing that, I pounded on the threaded portion of the tip of the arbor itself on the motor, and it bent sideways. So it's kind of really my fault in the sense that I didn't take precaution to find another way to get the bearings out of the housing, knowing ahead of time how soft this material is. In fact, this motor is made either in Taiwan or China, and they use very, 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 very cheap, very soft material. So it's my fault for not having acknowledged that and worked with that. Ultimately, it's their fault for not using material that's a little bit more substantial. But then again, there's a lot to be said. You can wax philosophy about engineering all day long. The problem is, you'd almost be right, no matter how you argued and whose side you were on arguing it. I like the thickness of this cutting wheel. The only reason I'm saying that is it's a 1/16 thickness, which is excellent because the last wheel I had, it seems like it was maybe, I don't know how to say it. It's like another 3/64 of an inch too thin. Either way, when I went to tighten it down, it just kind of buckled and went sideways. And I'm thinking to myself, again, that's manufacturer failure. That's product failure. That's the manufacturer's liability. They make things so cheap that they just cannot be used for any service cycle in their intended application, meaning the product simply doesn't work, meaning there's for them there's no exit strategy for bankruptcy, and they have to close the doors of their factory if their products don't sell because their products aren't made right. I don't understand why people can't learn this, but they pass along, they pay the price, they lose their share of the market, somebody else does market research, determines there's an opening in the market, there's a market need, and they sprout up, and hopefully they won't make the same mistake as their predecessors. But then again, you never know. So engineering in the world of manufacturing is just fraught with these types of oversights and mistakes made by people I suspect are leading the business that don't understand how design and engineering process works. So it's a very slow and very laborious. It's a dedicated business. It's not something you're going to get rich at overnight. So most manufacturing design engineering manufacturing business, most of them start as research and development, and they get funding for that definition. Research and development, they get research and development funding from larger private institutions of learning, local governments, local businesses, and they're telling them we're researching a technology. And once they catch a wind and they make that certain type of technology works, then they're able to sell they're able to sales pitch a working product that has somehow revolutionized the industry. And then from there, they attract major investors, not necessarily the U.S. government, unless they're part of the military-industrial complex, but that's a whole nother different story. And then they start to attract bigger investors, like on Shark Tank, which is an interesting show, one of the only very intelligent shows on TV I actually enjoy, respect, and appreciate, because it's true. Everybody is who they say they are on that show. But the point being, once a company has completed their research and development phase, which is, and then, they're no longer researching and developing products, they've established the beginnings of pedigree of engineering discipline and technology, the particular type of particular part of part or system or subsystem, they're going to establish themselves in the industry long term and be known for manufacturing, like Raytheon for radars, Hughes Aircraft for helicopters, Boeing for commercial airliners, Pratt & Whitney for aircraft engines, and even people like General Electric for light bulbs. They established themselves in the industry, but they start out as research and development institutes. They don't just get into the business and say, well, we're going to exit strategy this, and this stuff better sell in the next 2 weeks, or we're selling insurance, getting out of manufacturing, which is, of course, ridiculous. That's kind of an extreme and sort of a disrespectful, vitriolic example, but you know what I mean. Some of these people are better suited off, executives of some of these companies are better suited off just either running for Congress or just staying home and, collecting disability. Because I got to tell you, some folks that control the engineering world are not engineers, and that's a crying shame. They don't know what's involved. They think like non-engineers, and they force their non-engineering decisions on people who do know what they're doing, the engineers. And in the middle, the two shall never meet. You have one disaster after another. The well is drying up. The consumers' willingness to forgive people for poorly made products is now coming to its wit's end. For example, the way cars are designed these days, in the back and forth between performance and economy, luxury, safety, and as many parts as you could possibly put on a car versus longevity, people are starting to, just lose faith, and nobody's buying cars anymore because almost every single manufacturer, save for a few, are making crap. They're making it so quickly and so incompetently, and they're just shredding themselves. They're eating their own flesh. So, like I said, the world of engineering and manufacturing is in a pretty dismal space. It's a disabled business. So, but that's my 50 cents. We're gonna make this one continuous video. Like I said, these screws are gold. The arbor materials are not. These screws in the backside, right here, these guys are brass gold. Then, of course, the covering plates, the spring plates for the the covering plates for the brushes are like a brass gold, and the bolts that hold them in are brass gold. And I'm thinking to myself, let's show a little bit of class. So we have colors of, steel gray, have this nice blue gang and cover. I still need to get that 15 amp breaker switch, which I'm going to put in here, along with a continuous running continuous running capacitor, maybe 100 volts at 60 hertz, or a 90, or 95 continuous running capacitor with maybe like say 10 baud hertz. I don't know. I'm not entirely sure how it works, but I know that the lower the more you want the motor to slow down, the smaller the motor, the less material you want to learn. So you keep it as simple and as basic as taken down as possible. And the reason I'm going into all this, in a sense, to do singing the praises of the aesthetics of this, because it is turning out really nice. It's taking on a life of its own. It's meant to be an ultra high-speed cutting tool. When I make more money, I'm able to set up more tooling. I would like to make my own basic gearing for reduction gear, which there are plenty of places to hang a reduction gear transmission on this. I could always manufacture, an orbit gear, a carrier with 3 smaller gears, and an internal gear and an output shaft. And I could put a bunch of grease in that. But it sounds tedious. I don't have the machinery to do something like that. But somebody else maybe you'll do that for me, or maybe a couple $100, and all of a sudden I get set up with a production row, and I can make my own planetary reduction gearboxes out of light plastic housing, heat treated TO6061 aluminum gears, not pot metal, brass bushings, and we can get this output shaft to slow the hell down, because it's spinning at around 15,000, 20,000 RPM with straight rod juice, from a wall outlet. And I'm telling you, the thing, it is so loud, and it just wants to rattle and tear itself apart. Like I said, any imperfection in the arbor, they're sure there's going to be, but it's any deviance from absolute center line, and any point in a radius of any component as it stretches out lengthwise of the long axis of the object, the innermost object internally, as it's spinning. You can't have extra space on one side or the other. You can't have balance on either side, and imbalance on either side of the other. And then the farther out it goes from the support, the longer it extends, the thinner it is. Center line axis, invisible line down the middle of the motor itself. The farther out it gets, with that imbalance, or with that imperfection suddenly goes from 1/10,000th off at maybe 100 RPM, and then 1 inch to 1.5 inch. It's now 250 parts off, and then you raise the RPM up to 15,000, and this thing feels like it's going to liquefy your hands if you grab it, and you feel some serious heat coming out the back of the motor. It's not working to overcome it's working to overcome, the friction from the extra material that's slopping around. It's working against all the heat that it's generating too. And the darn thing, the tool, if you run a tool like that consistently, and it feels like the tool's tearing itself up, then it probably is. It might be tearing you up as opposed to a real hazard. That's why I'm doing as much research and development as I can on these output arbors. They have to be set up a certain way so that there's no tail vibration. I can explain it to the umpteenth degree, but the smoother the tool, the higher the RPM. Yeah. Anyway, so pause for effect. So I'm thinking once I get this everything trained up, I'll take it to a heat treating specialist, assembled. I have the motor assembled, and anyway, once I have this assembled the way I want it, with the cutting wheel centered and everything, obviously I'm not going to leave loose parts on it. But what I would do is take that cutting wheel and it's still, in the little centering O-ring, make sure it's absolutely centered, long axis, right angle, long axis of the input shaft. So, for no tool vibration. all the way vibrations cause. Anyway, I'm thinking a silly thought. So then the other thing is I want to maybe keep the tool as short as possible. Here's the thing. Here's the other challenge I'm coming out with. And I'm just explaining these in engineering terms. We have this radius here that I have to deal with, and I'm thinking to myself, for aesthetics, it does look good if I try to remove some of this material, just above the area where the screws joined together. I'm the type of person, I have to make that particular type of operation work. But if we did do that, we'd have more clearance on any side of this motor to maybe get a larger wheel, or set it back a little bit farther, but to get a wheel that's really close to the inside of this, to the outer so anyway, but I've got to set this arbor piece up short as I can set it. Practice running on no light load, no heavy load, no operations, and except for my skull. So anyways, so we're gonna set this up short as possible, secure it in place, take a picture of it, and then go ahead and bake this for 30 minutes on both sides. Anyway, I haven't dirtied up any plates or dishes, so I'm not going to wash or clean anything up. We are at the 26-minute mark. I'm thinking 25 to 30 minutes. It's a little bit better. I'm enjoying myself more. I am in lecture mode. I love discussing engineering topics. You notice we didn't talk about math at all. This is industrial design engineering. This is hands-on. This is where mechanics become inventors, designers, and engineers. The folks that work out the math, like Dr. Catherine Goebel, who is famous for abnormal and irregular geometry, she used math to figure out where the space capsule was going to land. She used irregular geometry to determine what kind of maneuvers would have to be take to descend through the atmosphere, go out of orbit, drop out of orbit, descend through the atmosphere, and splash down to the ocean. That's some serious calculating horsepower. And I do not look down on mathematicians. I praise mathematicians. By the way, a shout out to my good friend Chris Macroft, who's a dedicated and loyal employee of Boeing commercial aircraft. He's a good man. He's tutored me with math before. Very, very smart. Chris Macroft, I love you, brother. Shout out to your wife, Doreen, too. You guys are absolutely wonderful. You've been good to me over the years. But I tell you, I respect mathematicians, because without the math, there are a lot of things that we can't make. And there are a lot of things that we make, we can't make it work. So I have a few other engineering buddies. One of them passed away. His name was Frank Miller. There's another guy named John Lazar. I haven't seen him in ages. I hope he's doing okay. But I haven't seen him in about 3 or 4 years since the outbreak of COVID-19. Shout out to my other engineering buddy. I haven't seen him his name is Hector. He's an engineer. I did one automotive repair job for him. Who are the other engineers? Well, shout out to my friend Mike Snyder. Brother Mike Snyder. He's a good man. He's a mechanic. He's really smart. He's teaching himself welding. He's very, very, very difficult to get along with, like I am. And the thing is about engineers, we take things down to the very basic, the bone basics. I mean, you don't get any more basic than an engineer who's first been a fabricator, welder, mechanic, like Brother Mike Snyder, myself. We're really bosoms mates. We're very, very close and friendly, and we parted on sour terms. And I kind of yelled at him, and I was out of line, and I was working on his car, and I kept trying to explain to him, the concept of metallurgy and that structural analysis, structural failure analysis, and I was about ready to tell him and correct him, but I just kind of lost my strength at that point. Started arguing with him. They just pay me my money for my time, and I get out of here, and I get out of your hair. So we ended on a sour note. I need to look him up. I need to just drive over there and get it from me, because I don't have his number. Anyway, so I'm starting to slur my speech, which means I'm starting to fall asleep. which means I'm not talking about engineering. If I'm talking about humanities, I'll fall asleep within 30 seconds because I really don't care. But engineering is my thing. Now, folks, I want to show you I'm going to go ahead and check to make sure, because I have a meeting, an in-person meeting tonight at 7:30 in Fountain Valley. It's very important to be at. But then I'll be working on this unit some more after that. But for right now, I have to make a correction to my dinner order from Del Taco. I'm really upset with them. But I think I'm going to just sit down and do that. I have to get an O-ring to center this on this arbor. I need something to take up the space between the threaded shaft and, of course, the inner diameter of this wheel to center it. And it'll work. I've done it before. Then I need to go ahead, and if I can get my hands on a 15 amp circuit breaker, I need to wire that. That's really no big deal. You put it in line with the power side. And here's the other feature I just wanted to show you. In addition, and I'm kind of going back and forth in this discussion, it's disorganized, but this particular motor came out of a Dyson vacuum cleaner, and I know what you guys are going to say. These are high revving, high RPM, low torque electric motors with huge field windings and very small rotors. You know, why are you doing this, Jason? I said, I've told you, this is my first step in developing a high-speed homemade cutting tool, but I shouldn't say homemade because I'm thinking maybe I want to start getting past research and development. Maybe I want to start making my own tools too. But it's either that or I want to hook this up to an alternator and actually gut the alternator and make the alternator, turn 220 volts alternating current, about 2,000 amps, and maybe make a 220 arc welder, 220 stick welder that doesn't weigh any more than a shaving case instead of a big metal box. Just plug the thing in, run it like a drill, and the electric motor runs a welding alternator, which is a gutted car alternator. And then from there, you have your spouts, you have an independent wire feed welder with the 2 electrical leads, and you have your wire feed welder. You can have one manual or electrical. But I need more money to do that. Hey, you guys, hit the like button, hit the subscribe button. I know a lot of this is dry. I'm really going to keep it this because I enjoy this. I enjoy this more than I enjoy rocketry, for the simple reason that with rocketry, it's so involved, and it's just, rocketry is different. To me, rocketry, I'm more passionate and absorbed by. I can't get past myself with rocketry. Rocketry is more of a lustful pursuit where I don't want to interact with other people. But with this, it's more lighthearted. I have an enthusiasm for it, but not as deeply as I have an enthusiasm for rocketry. Rocketry is a deep lustful passion for me. I hate to say lust, but I don't know how else to describe an interest that is that passionate and is that extreme and emotionally extreme, except to use the word lust. So I may be the first one on YouTube to use the word lust in that fashion, but hey, there's a first for everything. So I'm going to close up the car. I'm going to say goodnight to everybody. I'm going to go ahead and center this on the arbor myself. I'm going to get that O-ring. I'll take this with me. I'll take this little peg post with me and make sure that I get the right O-ring. I'll explain to them first. I paid for both of these. And then I'm going to go ahead and get a correct dinner order, see if they give me something for free. So I'll get the O-ring, get a correct dinner order, and maybe I'm going to even get a 15 amp breaker switch that I can put in here. As far as running capacitor is concerned, I'd have to go to a place like JK Electronics in Westminster to do that, or Marvac Electronics, and those guys, everybody in the electronics business closes down at 5 p.m. I don't know what you're going to do, but if you want to chase business away, you don't want to serve your customers, that's up to you. A lot of those people are self-righteous. They don't really understand how business works, and they don't really care. They think they know everything they need to know. And of course, when you think you know everything you need to know, it's a clear indicator that you don't know squat. My name is Jason Wampler. This has been the Wampler Engineering Minute. I may or may not be tempted to shoot one more video tonight to show you the fruits of my labor for wiring this up. But I'm gonna wire this up. I'm gonna get this cutting wheel centered on the end of this arbor, and I may show you the fruits of my results tonight, but that will be after probably around 11 or 12 p.m. So, because like I said, that meeting in Fountain Valley is going till about 9:15. I will not start in Fountain Valley library area, my favorite shooting spot, until, you know, probably 9:30, 10 o'clock, and I won't be done wiring this until after that set time. However, if I can eat quickly, I may just go ahead and do that right now before 7:30, when I have something more to show before I have to leave at 7:30. So let's just see how time goes. All right, you guys, hit the like, hit the subscribe button. We'll talk to you later. Oh yeah, leave a comment too.